this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 8-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to graph using vertex form. So understand, when we go to graph a quadratic, we always want to graph using 5 anchor points. Alright, so we need at least 5 points to determine that something's a quadratic. Or, to determine that the graph is accurate. Now, some of the key points, like we always want to graph our vertex every single time. So that's always how I'll start, and then I'll find other key parts of it. Now, the vertex and the axis of symmetry, they kind of go hand in hand. All right, the axis of symmetry happens where x is equal to the h value. So on this one, our axis of symmetry is at x equals -1. Remember, when identifying the vertex or the axis of symmetry, we put a negative in this formula, right? The vertex form looks like this. And so because there's a negative in front of that h, we have to flip our sign when we identify things here. So on this graph, my axis of symmetry is occurring. Ooh, that was a rough dotted line. My axis of symmetry is occurring here at x equals -1. Now, when you're graphing, it's always a good point to label things as you're putting them on the graph, because then you kind of know what you intended to happen and where things should go. So you'll notice, like I wrote x equals -1 for that axis of symmetry, just to remind myself what it was. Now the vertex lies on the axis of symmetry. That means that it has that same value for my h. And then my k value tells me how much up or down it is on that axis. So in this case, because my k value is a 5, my vertex is at the point -1, 5. Now we always want to identify some other kind of key points here. A really useful one is usually the Y-intercept. So if I were to plug in a 0 for x, I would get my y value. So I'm going to go ahead and do that, all right? I'm going to try to do it a little bit mentally. So here I would do 0 plus 1, which is 1. And then I would square that, which is still 1. And I'd multiply it by -2. So this entire first part would be -2. If I add 5 to that, I get a 3. So this y-intercept is at 0, 3. Now remember, that axis of symmetry tells us that we can reflect points over it to get another anchor point. So while we have this point at 0, 3, I can also hop across the axis of symmetry to -2, 3, and that'll get me my anchor point. So now we always want to get another, another point that we can reflect, because we need 5 points and I'm down to 3 of them. Now remember, people always get kind of hung up here. You can plug in whatever values you want. You don't have to always just stick to certain given values, okay? I like to pick small numbers like 0, 1, or -1 just because it keeps our numbers easy. But you could pick whatever you want. You could pick 13,000 if you want. It doesn't matter. Now I like the easy numbers, so I'm going to use the number 1 for my x value, just to keep it small. So if I replace a 1 here, 1 plus 1 is 2. 2 squared is 4, so this set of parentheses is 4. -2 times 4 is -8, and if I add 5, I get -3. So over at 1, I'm going down by 3. And so again, I can do a reflection. So that red point at 1, -3 is 2 units away from our axis of symmetry. So if I go 2 units the other way to -3, I get my other anchor point. And so now we can go ahead and draw our nice curve. Please pretend it's nice. I don't know how to draw. Now another point that I think is always nice to get an anchor point in here is I use my A value. Remember, the A tells us how much the graph moves up or down when I move 1 unit to the side. So my Y-intercept was 1 unit to the side, and I could see that it's 2 units down, so that's kind of a way to confirm that I haven't made any mistakes. So let's go ahead and let's try another one. All right, so my axis of symmetry is at x equals h. So in this case, my axis of symmetry is at x equals 2. Now my vertex, I know the x part of it is on that 2, but my y part of it lands on k. So I'm going to go up by 1, and that's my vertex, 2, 1. Now my y-intercept is a little bit more of a pain. I'm going to plug in a 0 for x and kind of math it out a little bit. So here in my parentheses, 0 minus 2 is -2. If you square it, you get a +4. If you multiply 4 times -3, I get -12. And if I add 1, I get -11. So as you can see, sometimes these things grow really, really fast. So -11 would be right here. It fell off my graph. But we'll kind of call it good. I'm also going to move my writing for my axis of symmetry to up here. All right, so now once I've done my y-intercept, I can actually reflect it, right? So this one's 2 units away from my axis. So I can go another 2 units to 4, -11, and that'll give me another anchor point. Now I could pick whatever other value I want to plug in order to, to simplify this process. But remember how I was telling you the trick with our A value, how that can help us? That's what I'm going to do here. So my A value is -3, so I'm going to go to my vertex, go 1 unit to the side, and down by 3. And that just gets me a really easy anchor point at 1, -2. I don't have to do any arithmetic or any problem solving for it, really. And if I reflect that to 3, -2, I get my 5th anchor point that I need to draw my quadratic. So if your axis of symmetry is more than 1 unit away from the y-axis, it gives you just a really convenient opportunity to draw that curve. So let's go ahead and let's do this just one more time. All right, so our axis of symmetry is at x equals h. So x equals -1. So my trick with my A won't work on like I did with that last time, huh? My vertex is at -1, -4 because of that axis of symmetry. So there's 1, 2, 3, 4. Alrighty. So now I want to get my y-intercept, so I'm going to plug in a 0 for x to get my y value. So if x is 0, this set of parentheses is 1. 1 squared is 1, so this whole thing is 1. -4 gives me -3. So my y-intercept is at -3. And I can confirm that with my A value, right? Since there's no number written in front of the parentheses, there's a 1 there, which means I would go to the side 1 and up 1 to get that y-intercept. Then I'm going to go ahead and reflect that y-intercept across to -2, -3. so that I have a second anchor point. And then I want to find just one more. I'm going to find the one more by plugging in the number 1, but there's many things we could do, right? So I'm erasing that 0 that's up here, and now I'm writing a 1. So 1 plus 1 is 2. If I square that, I get 4, and 4 minus 4 is 0. So that's actually really nice because that gets me a Y-intercept, which we always like. 1, 2, 3, 4. Sorry, I'm second guessing myself on my drawing, making sure that it looks right. There we go. And so my reflection then would be at -3, 0. So now that I have my quadratic all plotted out, I can go ahead and try to draw a relatively decent U shape. So there we have it, guys. That is graphing using vertex form. Until next time.